Okay. Remind me to, yeah, I'm going to turn that on until we, okay. All right. So start with this one, especially to highlight the calculator skills. And we had 9.1 number, is that 8? 8, okay. And 12, okay. And 9.3 number 7, okay. All right. So this one from this is 9.2 number 13. So 24x squared minus 4x minus 4.
Oh,
switch.
I have another one. 9.2. Yeah, 9.2, number 6.
Number 6? Okay. From the first 9.2 or the second one?
First.
Okay.
So 9.2.
Okay. Actually, since we just want to mostly focus on calculator skills, let me see if this would be, since I'm in 9.2, number 6. Oh, that one's a purely GCF one, so yeah. Let me, come back to here to have an A not equal to 1. Okay. All right, so is there a GCF? Yeah, what is it? Yeah, GCF is the greatest one, so 2 is a common factor, but we're going to use, the GCF is always the smallest number or smaller, but the smallest number works. Okay, and there's no variable GCF. Remember, that's always the first question. Where do I start? Where do I start? Okay. So we pull out the 4, leaving behind 6x squared minus x minus 1. Now, I can cross out that original one because I'm done with it, but 4 is part of my answer. And I've got an A not equal to 1 trinomial, which means I need 2 steps. First, my ACB step. And what's my AC? Right, 6 times negative 1. And my B? Negative 1.
This is number 8.
This is number 13. Yeah. So 9.2, number 13. Okay. All right. So we've got negative 6 on top and negative 1 on the bottom. Okay. Now, hopefully you can think of that one mentally, but in order to show the calculator skills. Okay. So we'll go to y equals. Now, in your first one, you want to find factor pairs of your AC. So you put in your AC, which is negative 6, and you divide it by x. And also, I just also want to point out and recall that I did post this handout in Unit 2, which is a breakdown of the calculator skills as well. Okay, so these are the first 2 columns. The first 2 columns are x and y1. The calculator chooses x's, and negative 6 divided by x that the calculator chooses, 1, 2, 3, 4, and negative 1, negative 2, negative, so on. And so the calculator chooses those and divides them into negative 6, and it spits out y1. So our first column is x that the calculator chooses, and y1 is what happens when you divide your AC by x. So those first 2 columns are your factor pair, because remember, the opposite of division is multiplication, which means that when you divide by x, that means x times y1 is equal to negative 6. If negative 6 divided by x is y1, then y1 times x equals negative 6. So those first 2 columns, x and y1, are your factor pairs.
How did you get y1?
This y1 right here? You mean this right here?
Mm-hmm.
Okay. So the last column, the third column is y2. And y2 is your sum. You want to add the first 2 columns. So if you just have that in here, here's the x's that the calculator chooses. And I put it at 0, so I see negatives to the top and positives to the bottom. Error, of course, because you can't divide by 0. And y1. So when you divide your AC by x, you get your y1, which means that x times y1 is your factor pair. These are the different ways to get negative 6. 1 times negative 6, 2 times negative 3, 3 times negative 2, etc. And any decimals you just ignore. Now you also not only want to be able to multiply these to get AC, which the calculator just did for you, but you also want to know, well, what happens when I add these 2 numbers, because that's your B. So you go back to y equals and go to y2, and you want to add the 2 columns. You want to add column x plus column y1. And to get y1, that's under the variables button, which is right here. Vars. Okay? And now there's 2 menus. You want a y var, a y variable, so you arrow over. And now you just push enter, enter, because you're choosing function. We're not dealing with parametric and polar. So just enter for function, and then yes, y1 is what you want, so just enter. So vars, y-vars, enter, enter. And that's on that handout as well. Okay. And so now when we go to the chart, all we have to look in is this sum column. We're looking for -1, a sum of -1. And there it is. And there's our magic numbers, 2 and -3. Now 2 and -3, and I double check, yes, that multiplies to make -6 and it adds to make -1. But remember, this has a second step because it is a not equal to 1. So our first step is ACB, and our second step, right, is to split our middle. What is our middle variable? Just the variable. Just x, right. Because if it was a y, we use a y, or an xy, we have to use whatever variable's there. And now, yes, we rewrite 6x squared. Which one should I write first? Yeah, it doesn't matter mathematically, but if you have a choice, you want to keep a plus sign in the middle if you can. Double check that equals -1x, good. So you didn't change the value, just split the middle into 2, and you kept a plus sign in the middle if you could, so you don't have to do that extra sign flipping step. Now we do our 4-term grouping. Take out a 3x here. What can come out of here? Well, if we got a plus in the middle, we didn't have to do a sign flip, then we always pull out a positive GCF, which would be +1. Now, normally if there's a GCF of 1, +1, we say there's no GCF. Technically there is, but that means there's nothing changes. But because this makes our second binomial, we do have to write it. Okay? So we pull out the 3x, put up the parenthesis, and what's left is 2x minus 1, and plus, pull out the 1, and what's left is 2x minus 1. And here's our big GCF, 2x minus 1, and then the leftover bit, when we factor that out of both pieces, we're left with 3x plus 1. Oh, and there was an initial GCF of 4, don't forget that, it's part of the answer. Does that help? And with the calculator and with the, yeah. Okay. So we got a lot to go over here, so I'm going to speed ahead, but interrupt me if there's any questions or any confusion. So the next request was in 9-1. Let's see, I think there was another 9-2 question, so that was number 6, yeah. There we go. Yeah, oh, that was the other one we mentioned too. Okay, so this is 9-2, number 6. 9.2, number 6. Okay. So 3x squared. These are, remember, these are my versions, same setup, but with my numbers. Okay? But it's the same structure problem.
How is it you got 4 on the outside of the final answer?
Because that was my original GCF, and the GCF is a factor. Oh yeah, it's part of the answer. Now, I set it aside for a second because there's nothing else to do with it. Once you pull out a GCF, you're done with it, but it is part of the final answer. Okay, so I don't want to forget about it. It is part of the final answer. There's just nothing else to do with it. Okay. So never forget if you did pull out a GCF at the beginning, it is part of your final answer. So same with the, I'm sorry?
So you basically have like 2 GCFs, right?
No, there's a single GCF, but then when you do the, a not equal to 1 factoring, which uses both your ACB and then your grouping, which is your GCF, GCF, GCF. So then there's more GCFs just as part of the grouping method. But those GCFs form the binomials, not another outside GCF. Yeah. Okay. So here we've got a GCF also, just a numerical one like before, of just a 3. Okay. So 3, leaving behind x squared plus x minus 12. Okay. So that 3 is part of the final answer, but we're done with it right now. But I also have a equal 1, so I know that I only have one step, just my ACB. Because in order to get that x squared, what do I have here?
I'm sorry?
How do you get x squared here? What do I have here? Yeah, so there's no coefficient. I just have one step to find my magic pair of numbers, so I can go ahead and even just set up my answer. Now, if this is a minus 12 here, what's my sign pattern?
Negative minus.
Yes, the only way to get that negative product is with mixed signs.
Does it matter if you put that negative before that positive?
No.
Okay.
Well, you mean, what, put the negative here and the positive here?
It doesn't matter.
Order of factors doesn't matter.
Yes.
Yeah.
Okay.
So I've got, and I've got an AC of negative 12 and a B of positive 1. So negative 12 and positive 1. Now you can use your calculator. Hopefully with smaller numbers try and do as many of these mentally with homework. That's the whole point of homework, is to develop those mental skills and those strategies. But of course also be comfortable with your calculator to back you up under test pressure time or with really big numbers. So I know if I've got a difference of 1, I know I've got, I'm even going to put this is positive and this is negative. I know I've got mixed factors here. And whenever you have a difference of 1, because basically if you have 1 positive, 1 negative, it's a difference, that means you have consecutive factors. Just like here, this was a difference of negative 1, 2 and 3 are consecutive numbers. Okay, there's only a difference of 1 between them. That's what consecutive means. So I know these are going to have to be consecutive factors too. What consecutive factors multiply to make negative 12? Well, I've either got 1 times 12,
4 times 3.
4 times 3, yeah. It's either 1 times 12, 2 times 6, or 4 times 3. So, and I see that I've got, now wait, which one's positive, which one's negative?
The 4.
The 4 is positive, right. And a negative 3, that's going to give me a positive 1. Okay. Now, if you needed a calculator assist, especially with the mixed signs, then all you would do is instead, you'd have a negative 12 divided by x on top, and you can just leave this in for right now. X plus y1 in the second one. And then go to your table, and you'll see that we're looking for a positive 1 right there, 4 times negative 3. Because sometimes, even especially under test panic, that positive negative thing can kind of throw you off. So calculator is a perfectly good tool to check that. Question?
Are the tests, are they timed?
Yes. Well, you have the class period. You have the entire class period. Okay. So those are our two numbers. A was equal to 1, so we're done.
Yes, ma'am.
And so that's positive 4. Now this order does matter because I already set up my sign pattern. Okay? So it does have to be the positive 4 and the negative 3. Make sure you put them with the right sign. And I have my original GCF, and you're done. Remember, you can always check your work. I refoil this. X squared plus 4x and negative 3x is 1x. And then negative 12, check, and then distribute my 3. And I see I'm back where I started. You can always check your work.
How come the last part on that set we added, we would add the x to the 4 and the negative 3?
Because it would give you a negative, a positive.
Right here?
Yeah. Last problem, it was kind of similar, but you added the x.
Oh, right here?
Yeah.
Okay. So, because this is A not equal to 1, there's 2 steps. When A is not equal to 1, look what happens with your binomials. The only way, you can't, if you just had x times x, you get x squared, and A is equal to 1. But if A is not equal to 1, then this can't just be x and x. You have to have coefficients to get that 6. Okay? Now the coefficients could be 1 times 6, they could be 2 times 3, it's various, negatives and positives, and sometimes if it's a bigger it's bigger and bigger numbers, okay, or more choices, okay. So you can guess and check what those coefficients are, but this is a way to get there in a cleaner way, okay. It's kind of a guess and check method that helps your brain focus. But the problem is if A equals 1, then you've got coefficients on your x's. I'm sorry, if A is not equal to 1, you've got coefficients on your x's. Okay? If A is equal to 1, no coefficients on your x's. So when you find your ACB, those are your numbers. Because you know your x's are clean. Your x's are naked. Okay? And these are your numbers. But if you've got A equal 1, you've got coefficients on your x's, which means these are not your magic numbers. They're going to get you to your magic numbers. Instead, we call it our split middle. Give it the middle variable, split your middle to turn to 4 term, and your grouping method then will get you to your correct binomials. And you can see that your magic numbers here are not 2 and 3 here. It happened to be 2 and 3 here, but that's just a coincidence. It might not always be. Okay? Don't think those are your coefficients. Okay? That's just a coincidence on this one, because there weren't many numbers to choose from. Okay? But do note here, the magic pair of numbers are your constants. When A is not equal to 1, the magic pair of numbers are not your constants. Okay? But they're your split middle, which with grouping gets you to both your coefficients and your constants. Okay? These numbers will not necessarily show up in the end. They're going to get you to the end.
That's because they have the x, right? That's the only reason why we
Because the x here?
We have to do that.
Yes. Yeah, that's why I always say this is a split middle. Always look here, because usually it's an x, but it might be a y or it might be an xy. If you don't put the correct variable, then your middle will not be split correctly and your grouping won't work. So whatever that middle variable is gets tacked on to your magic pair of numbers. And notice, once you split your middle, do a quick add, negative 3x and 2x gets you back where you started, negative x. You didn't change the value. It's the same polynomial, just with 4 terms instead of 3. But that allows you to do 4-term grouping and find all 4 numbers you need, the coefficients and the constants, which are not going to be the same unless it's coincidence as this. Did that answer the question? So,
Can you show us an example that other one was an example? Well, no, not really. Because those 2 split numbers were still part of the answer.
yeah, again, that's just a coincidence. The idea is there's 2 steps, okay? And these, if the 2 steps, if not equal to 1, 2 steps if a is not equal to 1. So when you use your ACB, you're getting the numbers, the coefficients of your split middle. When a is equal to 1, you are getting your constants. When a equals 1, ACB, and you're done. Okay? When a is not equal to 1, ACB, but you're not done. Okay? Here, your magic numbers are your constants. Here, your magic numbers are your split middle coefficients. Okay. I'll make a note of that. Here, those numbers are your split middle coefficients. You tack them onto whatever your middle variable is. Okay. And here, that's when a is not equal to 1. Those are your split middle coefficients. When a is equal to 1,
That's when you do the substitution.
then these are your, no, substitution is a different method when you don't have, when it's quadratic in form. Okay? We can touch on that a little bit later. So when a is equal to 1, that's when your magic numbers are your constants in your binomials. Yeah. And since when a is not equal to 1, these are your split middle coefficients, that means you got another step to do. Here, these are your constants, so you're done. You just put them in because your x's are going to be naked because a equals 1, so you're good to go.
Okay.
Okay. All right, so let me get to those other homework problems, because we do have lots of new material to cover too. So we had a request from 9-1. Is it number 8-12? Okay. So 8xy plus 20x plus 2y plus 5. So, where do you start?
Just finding your GCF.
Yeah, is there a GCF?
Yes.
For everything?
No.
No. 8, 20, and 2 share a GCF of 2, but then there's that 5. If it's not for everything, there's 4 terms. If it's not a GCF for everything, it's not a GCF.
Oh.
Okay? Now, once we do our grouping method, then we're breaking it down into little GCFs. But first question is always, where do I start? Is there an overall GCF?
Okay.
No. And this has an XY, an X, a Y, and nothing, so there's no variable GCF either.
Okay.
Okay? Yeah. Now, now I see, what do I have? I've got 4 terms. Plus sign. So am I good to go?
Yes, ma'am.
With a plus in the middle, I can just put my groups up because I didn't violate any signs here. Okay? The subtraction in the middle, I would have to change this to subtraction to plus and negative, so I protected the sign of the last number. Okay, so my GCF of the first group, what's the biggest numerical GCF? And then variable would be an X, and here, 1. Now, if a GCF is 1, we usually say there's no GCF and we move on. But in this case, that matters because our little GCFs form one of our binomials. So if the GCF is 1, we have to write it. And it's okay for the GCF to be 1 in our second group. Okay? Now, if it's in both groups, that's a problem. That means we probably can't factor it. It's probably prime.
That 2y, it was a 1 for the GCF, so should you have put y1 or just 1?
Just 1. Yeah, it's not, y is not in common. And there's no GCF at all, so that means the only thing these can both be divided by is a 1. So we have to write it. Otherwise, we'd say, oh, there's no GCF, and we move on. But if in 4-term grouping, if the GCF is 1, we do have to write it. When we pull out that 4x, we're left with 2y plus 5, and then plus, and now our GCF is 1. We do need to write it, but of course that changes nothing when you divide things by 1. And now we have our matching, we turned a 4-term sum into a 2-term sum, and they share, these two terms share that big GCF. So when we divide out 2y plus 5, what's left in the first term?
4x.
And then plus 1 in the second one. Good. Good. Okay. And 12 was the other?
That's from
What number was that?
That was 9-1 from 4-term grouping in the first section.
Could you put 4x and then open bracket 2y plus 5 squared?
I'm sorry?
Could you actually instead of doing the whole dividing at the bottom,
Yeah?
could you like put 4x in open bracket 2y squared 2y plus 5 squared against it?
No, because 2y plus 5 squared, a binomial squared, would mean that these two things are multiplied.
So it's gonna be like
But they're not. They're added. This is not a binomial times a binomial.
So then you just write down the.
This is like saying 4m plus 1m. Okay? These are your variable, but instead of a nice simple clean variable like an m, it's 2y plus 5. Okay? But they're being added. It's not multiplying these two binomials. Does it see the distinction? Huh. Good. Other questions?
When's the other time where we do that?
Do what? With the binomial squared?
Yeah.
We're going to do an overview of that.
Okay.
Yeah. Okay. So this is one with a minus 15xy minus 9x minus 5y plus 3. Is there an overall GCF?
yes. No.
And we can take 3 out of this and this and this, or we can take 5 out of this and this, but yeah, if there's not everything, and they have different variables.
So it's
Okay.
not.
Right. Now, caution though, so now you say, okay, well I have 4 terms, so I'm going to do grouping.
Okay.
But
Okay.
then there's the negative y, the negative.
Yeah.
Which problem is
This
this?
is number 12 in 9.1. 9.1, number 12. 9.1, number 12, and this was number 8. Okay. So plus negative 5y, and that protects this as plus 3. Now, this is a negative 5y, and that's a plus 3. I do this before I put up groups. Otherwise, if I just put up groups here, then that negative belongs to this and that, and it would change this to a negative 3, and that would be an illegal move. This is a positive 3, and it has to stay positive 3. So you make sure there's a plus in the middle by changing subtraction to plus and negative. Make sure your last thing doesn't change. Now you can put up your groups, bless you, leaving the plus free. That's a free hanging plus. Okay? Take out your GCFs. Now when you make the sign flip, what kind of GCF do you take out? It has to be negative. Yeah. If you change from subtraction to plus and negative, you take out a negative GCF. And other than that, it's just a 1, but you do have to make it a negative 1. So 3x, leaving behind 5y minus 3. And then plus a negative 1, so now I can change that back to subtraction now and just do minus 1. And when I pull negative 1 out of there, that leaves me with a positive 5y minus 3. And if you didn't pull out a negative 1, then you'd have negative 5y plus 3, and they wouldn't match. And that's fixable, but why make your life more difficult?
So why not do divide by negative 3?
Because this isn't divisible by negative 3.
No. When it's something.
Oh, because it's a leading positive. That's another way to sort of remember. Yeah, if the leading term is positive, pull out a positive GCF. If the leading term is negative, pull out a negative GCF. So when you do the sign flip, pull out a negative GCF, but another way to remember it is, oh, I've got a leading negative, pull out a negative GCF. Yeah. Uh-huh.
Is it possible to actually rewrite the original equation before you factor out this?
Rewrite it, like put it in a different order?
Yeah.
Yeah, the order doesn't matter as long as you carry signs with it. This is positive, that's negative, that's negative, that's positive. So if you move it around, make sure you carry their signs with them. Yeah. And then there are occasions when, I don't have little GCFs for both groups, or I have little GCFs but my binomials don't match. And then what you want to try is maybe if I rearrange the original one, it will work. And if it still doesn't work, then the answer is no. But sometimes that happens. You have to rearrange the original one, and then you'll be able to make it work. But you have to be real careful to carry signs with it. Let's see. So you could also rearrange this if you wanted to put +3 and then -5y. But then that might not work out as far as matching GCFs. So 5y minus 3 gets divided out, and then leaving behind 3x minus 1. And if you had an original overall GCF, don't forget to put it in front, if you had one. All right. So our last request was for 9-3, number 7. Now by 9-3, that's probably not the one I just posted, but the last homework that y'all had, the 9-2, 9-3? Yeah. Okay.
Can we look at the last question?
Sorry?
Can we look at the last question?
For 9-3? For the last homework? Okay. So I've got number 7, and then number 10. Okay. So here's a substitution one. Okay. All right. So 4x to the 6th plus 12x cubed minus 27. Okay. Now you've got to test if this is quadratic in form, because you can see right away it's a trinomial.
I'm sorry.
Oh.
Sorry. It's number 7.
Number 7? Oh, yeah, that's number 7.
That is number 7?
Uh-huh.
On that one.
Does yours have x6 and x cubed?
If mine says 2x6
Yeah.
to 7x
Cubed.
minus 30.
Right, different numbers, same setup. Okay. Yeah, so, because everybody has different numbers. So when I do homework in class, I use the numbers I have, but it'll be the same structure. Okay? So if you still have, when you see what we do here, try yours again. If you still have problems, then I'll look at your numbers individually. And that's where Ask My Instructor comes in. Well, if you send me an email with Ask My Instructor, then I can see your number specifically if you have questions about that specifically as well. Okay, so no overall GCF. Now, I see that this is a trinomial, but it's not quadratic, because it's not degree 2 with a x squared and an x. But possibly it's quadratic in form. So my job is to test if it's quadratic in form, and if so, then I can use U substitution. Okay? So to test that it's quadratic in form, this is what I do. I set U equal to my middle variable. I'm not worried about the numbers. These should be variables here, and that should always be a constant. If this is not a constant, this is not substitutable. Okay? But I'm not worried about my numbers now. I'm testing if it is quadratic in form. So I take my middle variable, U equals x cubed. And now I square both sides. So I square that. And if I square the left, I have to square the right. So x cubed squared, which equals x to the, yes, power rule, multiply the exponents. And does that match my first variable? Yes, check. Okay? So that means U equal to my middle variable, square both sides, and if what I get equals my first variable, then I have a quadratic in form. Check, it is quadratic in form, which means I can use quadratic methods to factor it even though it's not quadratic. And so I'm going to do a U substitution. So anywhere I see U equals x cubed, I put in a U. Okay? So I rewrite this problem as 4, and x to the 6th I can write as U squared plus 12U minus 27. And now I just do my regular old factoring. Okay? Now this is an a not equal to 1, so I have to do all that tedious a not equal to 1 thing. Okay? So I find my ACB. My AC is, negative 27 times 4, negative 108. And my B is positive 12. So times plus negative 108, 12. I note that my sign pattern is going to be mixed because of the negative 27. Okay? And I